I'm here with another video for IB Math AASL. Still in the core book here, we're taking a look at section C from chapter, I believe this is chapter 12, right? Let's see. Yeah, chapter 12. We're taking a look at frequency tables here. So in the previous sections, we talked about how to find the mean, the median, and the mode, but that was when we had individual data. But if we have frequency tables, then we need to think a little bit more about how we're going to calculate those values. So first of all, what is a frequency table? A frequency table looks like this here, where we have one column that represents the values, meaning the outcome of the random variable, and another column which represents how frequently those values come up. Now, identifying the mode is very obvious. You're just going to look at where the highest frequency is. But to find the mean and the median is just a little bit more challenging. All right. We'll show you here using the formula how to get it, but then we could also show how to get it from the calculator. If we're trying to find the mean, okay, so we have our values and we have our frequency. What we're going to do is we're going to do the product of those two things, the value times the frequency. So 3 times 1 gives us 3. Now, why are we multiplying it times the frequency? Because we're trying to add up all the possible, all the actual values that we have in this whole distribution. So if there's 1, 3, we multiply 3 by 1, and therefore we have 3. 1, 4, same thing. But there are 3 5s. So in total, if I'm adding up all the values, there's 15 added to that data set. Keep going, 6 times 7, etc. Now, once I get down here to 278, 278 is the total of all of the values. So in order to figure out what the mean is, I'm just going to take that 278 and I'm going to divide it by our frequency, which we can see here, the sum of all of the f's is 40. So the mean is going to be 278 divided by 40, which happens to be 6.95. For the median, okay, so we know that the median value is going to be in the n plus 1 divided by 2 location. So in this case, we have 40 data points, so therefore 41 over 2, 20.5. The median is going to be in the 20.5, or the average of the 20th and the 21st value. So what we're going to do is we're going to count cumulatively. So we see we have another column here for the cumulative frequency. We first have the 1 here because, well, there's only one value at or below this value of 3. When I get to the value of 4, cumulatively I have 2 because there are 1, 2 values here. Then I have a 5 because it's 3 plus 1 plus 1, 12, 27, 35, and 40. Right, so here's our cumulative frequency. But like we said, we're looking for the average of the 20th and the 21st values. So if I go down cumulatively, not quite here, but here in this bar where the value is 7, both the 20th and the 21st values exist. Therefore, both of those values are 7. Therefore, the median is 7. Let's take a look at this example here. It says the table below shows the number of aces served by a sample of tennis players in their first sets of a tournament. We have the number of aces, 1 through 6, and their frequencies. All right. So even though the mode is the last question, I'm going to start with that one because it's the easiest. Frequency, moop, here's 18. That's the biggest number. The mode is going to be 3. All right. The next one I'm going to keep working backwards here is the median. How many values do we actually have here? We have 55 data points. 55 plus 1 is 56. 56 divided by 2 is 28. So I'm going to count cumulatively until I get to 28. 4 plus 11 is 15. 15 plus 18 is 33. That means that I've passed that middle value of 28. So the 28th value is here in this column here. So therefore, the median is going to be 3. To talk now about A, the mean, I'm going to do 1 times 4 plus 2 times 11 plus 3 times 18, etc. on out. And when I do that, I end up getting 179. And therefore, the mean is just going to be 179 divided by 55, which is also very close to 3. It ends up being 3.25. So in this case, we find that the mode and the median are both 3, and the mean is 3.25. So they're all very close together, which, as we'll see in just a little bit, kind of makes sense because this distribution starts out small, increases and then decreases again. So we have that kind of symmetrical distribution. That's it for this lesson. I'd like you guys to work on here in page 315. We're going to do 1 through 7 odd. 1 through 7 odd. And I'll write that into our Google Classroom. Have a great day, guys.